Okay, students, so 1000. Okay, so how I got 1000? So I'm just converting the units here. Okay, so this is gram, we want it in milligrams per liter, so hence it will be 35.45 into 10 to the power 3 milligrams. Okay, so we'll substitute all these values in this equation and we will get the amount of chloride ions present in your wastewater sample. Okay, so this is how to determine the chloride content. Okay, so next, the third chemical characteristics here is your nitrate. Okay, so third is your nitrate content or nitrogen content. Nitrogen content. Okay, so nitrogen is also one of the most important chemical parameter for us to determine in analysis of wastewater. So why it is important, and how many types of nitrogen are there, so we'll study in this. So it's a little bit bigger than the others. So yes, we'll start it. Okay, so first, okay, so what is the main reason of studying this nitrogen contents? Okay, so first is it indicates. Okay, so it indicates, what it indicates, it indicates uh, okay, so it indicates the presence of organic matter. So whenever you find any nitrogen content in a sample of water or wastewater, so that indicates that there is some amount of organic matter in it. Okay, so it indicates presence of, it indicates the presence of organic matter. Okay, so some amount of organic matter will be present if there is nitrogen content. Okay, if you find any type of nitrogen, so we'll learn about the different types. So there are different types, 4 types are generally, but if you find any of the nitrogen present in a sample of water or wastewater, that means that particular water or wastewater is contaminated with organic matter, or some organic matter is definitely present. Okay, second, why it is important? So nitrogen is important. Nitrogen is essential for growth. It is essential for growth. So all the bacteria and algae, they use nitrogen for their growth. Okay, essential for growth. So also called as biostimulant. Okay, called as biostimulant. Okay, okay, so how many types of nitrogen are there? So the types of nitrogen, there are different types of nitrogen, mainly 4 types. Okay, you may get different other types also, specifically with respect to wastewater. Okay, 4 types are present. Okay, so first is free ammonia. Okay, so first is free ammonia. Free ammonia or ammonia nitrogen, or ammonia nitrogen. Okay, second, organic nitrogen. Second is organic nitrogen. Okay, or this is sometimes also called as albuminoid. Okay, so this is sometimes called as albuminoid. Albuminoid nitrogen. Okay, third type of nitrogen is in the form of nitrites. NO2, and last is nitrates, that is NO3. Okay, mainly these are with respect to wastewater engineering. Okay, these are the most important types of nitrogen with respect to wastewater engineering. One is free ammonia or ammonia nitrogen, organic nitrogen or albuminous nitrogen, nitrates NO2, and finally it's nitrates NO3. Okay, so we'll discuss about all this little briefly. Okay, so you'll get this in notes also, so you refer both the lectures and the notes for your overall understanding. Okay, all right. Okay, so first was your free ammonia or ammonia nitrogen. Okay, ammonia nitrogen, okay, so the presence of ammonia nitrogen depends upon the pH. Okay, so depends upon pH. Okay, how it is dependent on pH, this will be clear by this reaction. Okay, so this is ammonia reacts with water, this is a reversible reaction. Okay, you form ammonium ions, this is ammonium ions, and you have hydroxide ions. Okay, so it depends on the pH. How? When your pH is greater than 7. Okay, when pH is greater than 7, ammonia is predominant, and when pH is less than 7, ammonium ions are predominant. That means if the pH, okay, if the pH of this reaction is greater than 7, then in the sample of wastewater you will find mostly ammonia. Okay, whereas if the pH value of the wastewater is less than 7, okay, in that case the predominant, or in the wastewater mostly you will find ammonia in the form of these ammonium ions. So that is what this means. Okay, all right, so next is your organic nitrogen. Next is your organic nitrogen. Okay, so what is organic nitrogen? Okay, or how do you determine this organic nitrogen or albuminoid nitrogen? Okay, so there is a method to determine organic nitrogen. The method for determination of organic nitrogen is Geldal method. Geldal means KJELDAL, Geldal method. Okay, So no need to study this in detail, it's not required for you. But how to determine the content of ammonia nitrogen? Okay, we determine that by this method, that is Geldahl nitrogen, okay, or Geldahl method. Okay, so how to determine? Okay, what you do, you take some wastewater sample, and then boil. Okay, you boil the sample, which removes ammonia, ammonia as in the free ammonia. Okay, then this will digest the sample. So after boiling, whatever sample is left, that is called as digested sample. Okay, or sample which is digested. After that, okay, so I think it is clear. Wastewater sample, okay, is first boiled, okay, and then after boiling, your free ammonia is removed. Okay, so it gets removed and then digested. Okay, means this, after boiling, the sample that is left will be called as digested sample. Okay, all right. So now in the digestion, okay, in this digestion, in sample digestion, the organic matter that is present, okay, organic matter which was present gets converted to ammonia. Okay, the organic matter gets converted to ammonium, sorry, not ammonia, it's to ammonium, and this ammonium is measured and calculated. Okay, so this ammonium is then measured and calculated. Okay, and then this is calculated. So this is how you determine the quantity of organic nitrogen or albuminous nitrogen. So this is called as Geldahl method. Okay, also there is another method, okay, which is called as so this is called as Geldahl method. Okay, so there is one more term that is called as total Geldahl nitrogen. What is total Geldahl nitrogen? The total Geldahl nitrogen is called as TKN in short. Okay, so TKN equals to organic nitrogen plus ammonia nitrogen. Okay, so TKN is called as organic nitrogen plus ammonia nitrogen. So the method of determination of TKN is same, okay, just like the Geldahl nitrogen, but here only difference is that ammonia is not driven off before the digestion step. That means in this total Geldahl nitrogen step, see here earlier what was the case, wastewater sample was taken and it was boiled, and because of this boiling it removes the ammonia, so free ammonia is already out of this sample. But to determine total Kjeldahl nitrogen, since TKN is equal to organic nitrogen plus free ammonia or ammonia nitrogen, means hence this nitrogen or this ammonia has to be present, and hence boiling is not done. Okay, so if you don't boil, then there will be ammonia that is present inside the wastewater sample. Okay, rest everything is same. So wastewater sample digested but ammonia not driven off. So ammonia digested but ammonia not driven off. Okay, and then okay, then this is got converted to ammonium and then it is measured. Okay, then ammonium is after digestion, ammonium is measured. Okay, that is after digestion. Okay, so the simple step, everything is same just like this process. Okay, except that removal of ammonia is not done in this. Why it's not done? Because TKN is summation of organic nitrogen and ammonia nitrogen or free ammonia. So it is mandatory to have the free nitrogen. So if we boil it, so this will go out. So that is why we don't boil it. So this stays, and then the total ammonium ion after digestion, then it is digested, and total ammonium ion that is obtained is calculated and measured, and then that is called as TKN. Okay, which is again organic nitrogen plus ammonia nitrogen. Similar, but that driven off is not there. Okay, so next type of nitrogen is your nitrites. Okay, next is your nitrites. Okay, indicates what it indicates. Nitrites indicates partially decomposed matter. Okay, so this indicates partially decomposed organic matter. Okay, or you can also say that treatment is still incomplete. Okay, treatment of wastewater is still incomplete. So if you find lots of nitrites, NO2, in your wastewater sample, this will mean that your wastewater sample is not fully oxidized or decomposed, it is still partially decomposed. That means there is still some form of nitrogen available. Okay, which is some form of organic matter is present. Okay, so treatment of wastewater is still incomplete. Okay, all right. So finally you have nitrates. Okay, so what is nitrates? Nitrates is NO2. Okay, so nitrates is the end product. Okay, it's the end product of aerobic oxidation, one of the end products of aerobic oxidation. So that means if you have majority of nitrate, that means your wastewater is completely oxidized. Okay, so it indicates completely oxidized organic matter in wastewater. Okay, all right. So after that, the next characteristics is fourth characteristics is fats, grease and oil. Okay, so fats, grease and oil. right? So oil or fats or grease is one of the most hardest thing for the bacteria, or most hardest material for the bacteria to oxidize or to remove or to digest from the wastewater. Okay, it's the most hardest because it is most stable. Okay, so fats, grease, they are the stable most stable compounds, organic compounds, most stable organic compounds, hence not easily decomposed, decomposed decomposed by bacteria. Okay, so bacteria, they are not able to, or very easily they cannot decompose or oxidize anything which is any wastewater which has fats or oil or grease. Okay, so because they are most stable organic compounds. All right, and from where these things can be obtained, means the wastewater which will carry these things, from where you will get that wastewater, mainly from kitchen. Okay, so from kitchen you will get what? Okay, butter, we use butter for food, oils, vegetable oils. So from there your wastewater will collect oils. Okay, then garages. Okay, garages, from garages, workshops. Okay, factories, we will get grease and oils. Okay, so grease and oils can be obtained, or the wastewater gets grease and oil when they come from garages, workshops and factories. Okay, all right, next. And generally there is very since they are more stable, so then their oxidation is not that possible. Okay, so what treatment unit is used to remove grease, oil and fat is skimming tank. Okay, so skimming tank is a type of treatment unit is used for fat and oil removal in waste water treatment plant. Okay, all right, so moving on. So this should be finished very fast because this is theory parts. Okay, fifth is your sulfates, sulfides, and hydrogen sulfide gas. Okay, this is sulfide, not sulfate. Hydrogen sulfide, DE. Okay, hydrogen sulfide gas. Okay, all right. So this is also one of the most important chemical parameter. Okay, so how this is formed? It's formed due to decomposition. Means how in wastewater you will get sulfates, sulfides and H2S gas. Okay, we will get these three in wastewater by the decomposition of sulfur containing substances. Okay, when sulfur containing substances. So if our wastewater carries any substance which contains sulfur in it, so it is destined to have sulfates, sulfides and H2S gas. Okay, so if your wastewater is contaminated with sulfur containing substances, at some point we will get, or we will obtain, or there will be presence of sulfates, sulfides and H2S gas. So that will always be there if a wastewater is contaminated with sulfur containing substances. Okay, also sulfur is required in the synthesis, so it is not necessary. Okay, so we'll move on. Okay, so one more important thing, okay, note for you. Okay, so why this is study of sulfate is very important, because anaerobic bacteria, now anaerobic bacteria reduces sulfates to sulfides and to hydrogen sulfide gas. Okay, so it will be clear by this reaction. So sulfate, this is sulfate ion, okay, plus organic matter, so there will be bacteria, this is anaerobic bacteria, okay, anaerobic. So reduction is taking place, so this process is called as reduction, it's not oxidation. Okay, so see, oxygen will get removed here, so you get sulfide. Okay, so sulfide ion is obtained along with some byproducts. Okay, so from sulfate, okay, by anaerobic bacteria they are reducing, okay, by the process of reduction, okay, by the process of reduction sulfide is obtained. Okay, and then again this sulfide same anaerobic bacteria, okay, will be reduced and it will form hydrogen sulfide gas. Okay, it will form hydrogen sulfide gas. So this is very bad smell is rotten eggs. Okay, so the smell when you produce hydrogen sulfide gas in wastewater, it will smell like rotten eggs. All right, also, okay, also this H2S gas, now this H2S gas that is produced, H2S gas produced is oxidized. Okay, is oxidized to sulfuric acid. Okay, so there are certain bacteria in the wastewater which can oxidize the H2S gas that is formed in these steps. Okay, H2S gas is formed in these steps, so there are some bacteria, okay, sulfate forming bacteria, which can oxidize the H2S gas to sulfate. Okay, sulfate means it's something like that. Okay, you have H2S gas. Okay, I'm just writing, it's not a actual chemical reaction, but I'm just showing it to H2S gas. So in the presence of that bacteria, this will oxidize. Okay, and there is obviously water. Okay, so this will result in H2SO4. Okay, so H2 will come from this, and so it will form this is sulfuric acid. So what happens is that when you form sulfuric acid, so this results in, okay, so this results in corrosion. Okay, so main problem, so results in corrosion of sewer crown. So that is why in the morning class I told you about crowns and invert of a sewer. So what happens is that, you remember the diagram, underground conduits, there is a sewer, okay, circular sewer, let us assume. Okay, so this is the crown. Okay, so this part is the crown. Okay, let's say you have wastewater here. Okay, so this is your wastewater. So what happens in this wastewater is flowing through this sewer. Okay, and then during this your H2S gas is produced, and then this H2S gas is converted by the bacteria into the sulfuric acid. So what will happen if sulfuric acid is produced? Since H2S gas is gas, so it will be released from this wastewater, so H2S gas will be present here, and then that H2S gas will be converted into sulfuric acid. So there will be droplets of sulfuric acid which will result in the corrosion of the crown, sometimes the invert also. So overall the sewer is damaged. Okay, so this will result to sewer corrosion. So this is very harmful. Okay, so that there can be questions from this, so this is very important. Okay, with respect to the sulfates. All right, so next class we will go or we'll study about the oxygen. Okay, so oxygen demand. So next important parameter is your oxygen demand, or you can just say dissolve oxygen. Okay, so it is dissolve oxygen. Okay, so students, please study till this point. We'll be giving you notes daily basis. Okay, so study. There is this days are you're not having any classes, but as a student you should not forget your duty. So your study should never interfere with any events, so you should always continue your study. So study till this point. If you have any doubts, you can obviously ask. Okay, so thank you.